Now picture this, a forest after a storm. You have one tree that survived, a pretty big one, a tall, deep roots, thick canopy, and now, because it survived, it captures more sunlight than before. The roots of this tree drink a lot more water, it grows bigger, and next storm, it survives again. Meanwhile, smaller trees, the ones that were almost there, well, they are buried under the fallen ones and under, smaller trees. So they get much less light, less water, and they shrink and eventually die and disappear. Of course, nobody designed this. No algorithm decided which tree wins the race of life, but the outcome is the same as your YouTube feed or your Twitter timeline or any other social media out there, wherever there is a feed that you don't directly control. The big get bigger, the small disappear. Some people call this how the world works. I call it internet is a disaster. And I think that we are both right, and that's exactly the problem. I'm Frag, and this is Data Science at Home. Today we are going deep on one of the most important dynamics in all of the science that you know out there, especially the one that regulates social media. And also, I will try to explain why the platforms that you use every day have weaponized this very concept from nature against you. I call this episode Nature's Algorithm, Why the Rich Get Richer and What the Internet Broke. And of course, don't get worried about that equation there. It's going to be very clear in a few minutes. Here is the typical roadmap of the episode. I'm going to cover, of course, the science behind these effects. Of course, the version that has been given to us by nature, or how nature evolved in applying this type of dynamics. Then, of course, how the internet works and what the platforms actually built, the damage, and the fix, hopefully. So let me start from the science or the scientific part, which is the Matthew effect. So back in 1968, sociologist Robert Merton studied how scientific citations worked. Okay, so he noticed something quite strange, that papers that were already well cited got cited more, which is typically what you probably have observed already also in many other dynamics out there. And that was not because they were better, but because they were visible. And so other researchers found them first, they cited them, and they kind of triggered this mechanism of enhancing visibility until that particular work or paper became the most cited one. Now, he named this effect the Matthew effect from the Gospel of Matthew, which I quote, "For whoever has will be given more, and they will have an abundance. Whoever does not have, even what they have will be taken from them." 2,000 years ago, and it's still, in my opinion, the best description of how YouTube recommendation algorithms work. In network science, this effect is called preferential attachment, which is a concept that has been formalized by Barabasi and Albert back in 1999, and I personally studied, of course, at the university, and many other students, of course, out there studied with graph theory. It's a very well-known concept in graph theory. It has one simple and brutally simple rule, which is new connections are more likely to attach to nodes that already have many connections. And of course, Barabasi and Albert make the example over graphs of nodes and connections, but the concept can be generalized to many other dynamics out there. Now, if you model this from a mathematical perspective, you get something that is called the power law distribution, okay? Also called a scale-free network. And this particular distribution shows up pretty much everywhere. Cities, for example, you have a few mega cities and many, probably millions of small towns. Wealth, you have a handful of billionaires and billions of people with almost nothing. But also web links, so artificial things. Think web links, web pages, a few pages with billion of backlinks and most pages with zero. And of course, followers, since we live in the era of social media. it's no news that we have a few accounts with hundreds of millions of followers, but most accounts are pretty much talking to nobody. This is not a coincidence. It's a structural property of systems where so-called early advantage compounds, right? And where exactly this type of laws are in place. So the preferential attachment is something that is extremely simple from a mathematical perspective or statistical perspective. As I just said, you have like this probability of attaching to node I that sign is proportional to the degree of I itself, which basically means the more connections a node has, the more likely new connections will choose it. And this is your YouTube feed, Spotify, Twitter algorithm, Instagram, pretty much any social media platform follow exactly this rule. All right. I was having a conversation with a friend who does swarm robotics, and he had a point because he said, "Well, this is how nature works." He had a point in a way, because in biology, and when we say nature, we actually mean biology. There is something called positive feedback, a positive feedback loop, right? Which are everywhere in biology. If you think of swarm robotics, you see, ants, for example, deposit pheromones on a path. More ants follow the path, more pheromones get deposited, and you have this like exponential growth of pheromones. So a useful path kind of emerges from local rules. There is no central planner, but the shortest path wins, and all others fade, because that shortest path gets amplified, right? Same thing in evolutionary biology. Sexual selection creates runaway feedback. The peacock tail started as a small signal of genetic fitness, but then females preferred it slightly. I'm mentioning evolutionary biology here. Males with bigger tails reproduced more, of course, because of the effect of females, and the tail grew. Now, it's kind of absurd, but peacocks can barely fly now. And that's exactly because of millions of years of evolution, where nature selected the ones with the bigger tail. But the feedback loop ran to its logical extreme in that case. I will mention what the negative feedback is in a few seconds. The third scenario where all this happens is ecosystems. Think about of apex predators at the top of the food chain are quite rare, but they actually control everything beneath them. A keystone species removed destabilizes the entire network underneath, right? So yes, nature does use what is very well known as rich get richer model. It's a powerful mechanism for selection and coordination. But here's the critical thing that probably my friend was skipping, the presence of the negative loop, so the negative feedback loop. Nature does not only run positive feedback, but it also runs within a system of constraints, right, which we call negative feedback loops, which are mechanisms that actually push back when a signal gets too strong, right? So for example, when population grows, food gets scarce, and then as a consequence of that, population starts shrinking again. Or one predator species dominates, then the prey population diminishes and eventually collapses, and now the predator starves. One tree wins, it shades out competitors like the small trees, but eventually it falls, creating a gap, and now new competition begins, and the small trees are back in the business. So in dynamical systems theory, this interplay between positive and negative feedback is what produces stable oscillations, diversity, and resilience. Okay, and there is one law that regulates this, which is the logistic equation, the equation that you've seen at the beginning, which is this one. So it's a ordinary differential equation for those who want to be fancy. But essentially what it is I say it for the people on the podcast. it's the derivative of n over time is equal to a positive feedback component, which is usually r times n, and the negative feedback component, which is 1 minus n divided by k. Okay. Now, if you're watching this as a video, Rn is the positive feedback, and the other component is the negative feedback. So essentially, Rn is the the growth proportional to the current population by a factor r, and 1 minus n divided by k is the negative feedback, that is the carrying capacity k that tries to resist unlimited growth. Okay, so you can grow until you kind of plateau towards a capacity, the carrying capacity, and then you don't grow anymore. That's how nature works. Now, without that negative term, you get exponential explosion, and then you have collapse, right? That's why nature was a lot smarter than humans, because nature is not purely rich get richer. Nature is rich get richer under constraint, okay? That's what makes it, first of all, different from social media, but definitely much more robust. And why I mention social media, it will be very clear in a few minutes, because that's in fact what we broke about the internet. Now, early web, probably very few people here remember, at least not the youngsters around here remember IRC. IRC was the very beginning of the internet, at least when it comes to social interactions. I mentioned that in another episode. Feel free to search on the official website, datascienceathome.com. It's my favorite example because things were pretty free there. They were not controlled. So what you wrote was not like made viral by someone. There was no feed. And so the opinion of a single user mattered, regardless if that user was a VIP or a normal user or a hyper-connected user. There was no concept of connection in that case. Now, on IRC, the opinion of any person counts as much as the opinion of any other person on the channel. And why is that? Is because IRC had and still has no algorithmic amplification, as I said. There's no feed, okay? There's no engagement score. There's no system that says these messages from this person should be shown, for example, to 10 times more people, as it happens now on the social media that you know. So everyone appears in the same channel. Text is text. You judge the message, not the messenger's follower count. The early web was exactly like that. It was very similar to this approach. So PageRank, for example, was designed to judge relevance, okay, not popularity of the popular. So a small, well-linked website on a niche topic could, back in the days, definitely outrank a major portal, and it typically did. Okay, so what happened? Well, somewhere around 2009, 2012, we had social media platforms that made one fateful decision. They needed to maximize one metric, which is time on the platform. Okay, so no more time on the platform means, of course, more ads shown, which means more revenue. Okay, as simple as that. So their business model was and still is designed around the concept of spending time on the platform and keeping you hooked on the platform. Why? Because the more you stay on the platform, the more you stay in my shop, quote unquote, and so the more advertisement I can throw at your face, right? That's the business model of social media. There's no secret about that. So to maximize time on platform, what they did was building recommendation systems trained on engagement signals, likes, shares, comments, watch time, all that stuff, which seems reasonable from a marketing perspective, or if you are the owner of the platform. But it has one amazing problem, which is engagement is not the same as value. So engagement optimizes for emotional arousal, social validation, novelty, this infinite scroll, which gives you always new stimulation, parasocial bonding, like you feel close to the creator. You can actually send a message. They will probably ignore you, but you can send a message. You can say, knock, knock, hey, Taylor Swift, I send you a message, and probably she, living in the dream that she's gonna read it. Now, what this system does not optimize for is, of course, accuracy, nuance, diversity of perspective, long-term well-being. So now you have a positive feedback loop, but you have just one that has been trained on the wrong signal, right? And that's a problem because then you have something that I call the amplification machine. Well, I call, big word here. It's basically that. So basically, this is how it works algorithmically. You post a video, it gets shown to a small sample, let's say 1,000 people, when you're lucky. The algorithm measures, click-through rate, watch percentage, like ratio, comment velocity, and many, many other metrics that are not even known to us. If those numbers are high relative to a baseline, which we also don't know, the video gets shown to, let's say, 10,000 people. And then, they keep amplifying this if the metrics match to 100,000 people, and then to 1 million people, and then to 10 million people. And then you understand how, with this simple law, that particular video becomes viral, as we say. So the rich get richer dynamics now operates on engagement rates, not just follower counts. But engagement rates are correlated with existing audience size, because, of course, larger channels have trained audiences who engage more reliably. Platform promotes established creators more because they are lower risk, of course, for them. And new creators start with, pretty much zero signal. So the algorithm cannot really distinguish them from, let's say, noise or spam. And so the result is a winner-take-most distribution that gets steeper every year. So entering and removing that barrier for new creator becomes more and more difficult. Now, what this breaks? Well, first of all, I want to say that we don't have carrying capacity to go back to that negative feedback that nature utilizes. And that's the key difference from nature. I want to stress on this before I move forward to other concepts. So in a forest, there is a physical carrying capacity, okay? There's only so much sunlight, water, soil, resources, right? Minerals in the soil and stuff like that. So the tree cannot really grow forever indefinitely, right? On YouTube, however, there is no carrying capacity for attention in the algorithm's model. And so the platform's goal is to capture all of your attention. The algorithm has no term like the 1 minus n divided by k, the negative feedback loop that I showed you before. It is purely r times n, so it's only the unbounded growth for the winners and starvation for everyone else. That's how YouTube works. Well, all social media works. So this is why some people are, when they say, about this, the way they understand how social media and the internet works with respect to nature, they are partially right. The dynamics are natural, but partially also wrong, because nature has these corrective mechanisms that social media platforms removed on purpose, actually. So now the internet didn't break because it's a bad idea. The internet broke because the people who built the feed decided that removing negative feedback was good for their business, okay? It's not because negative feedback is bad. Actually, quite the opposite. Negative feedback is extremely good. That's why nature uses it. Now, let me go ahead and tell you what this breaks. Because, we have three concepts that I want to clarify. The first is epistemic stratification. So when the algorithm amplifies based on engagement, you typically have extreme polarizing content that gets more rich than nuanced content. High production, influencers dominate over domain experts. That's what we see. We are seeing this. We've been seeing this for a few years. These super famous influencers that think they know everything, and then we have the domain expert who actually has absolutely no visibility. Emotional truth, this feels right to my tribe idea that outperforms empirical truth. So over time, you get this epistemic stratification, a world where your information diet is essentially determined by what the algorithm learned would keep you watching, okay? Not what is true or useful. The algorithm is optimizing towards a metric that I just explained, which is not truth, is what keeps you on the screen as long as possible. And this is, of course, not a conspiracy. I hope that you people can verify all this. It's an optimization process with the wrong objective function, and it's not it's not something bad. It's wanted. It is probably bad, but it's wanted. It's designed. Then we have the long tail paradox. Now, in 2004, Chris Anderson wrote a theory which was called the long tail, an optimistic theory that the internet would democratize culture. Now, with infinite shelf space, niche creators could find their audience. The long tail of human diversity would finally have a platform. Of course, it didn't happen that way. The algorithm compressed that long tail, because technically, well, you can upload anything, but the recommendation engine actively routes attention toward the heavy hand of the distribution. The long tail does exist, but it's invisible or pretty much ignored by the algorithm itself. And then we have the swarm failure mode. Now, this is something that I was discussing with a friend of mine who does swarm robotics. Swarm systems fail catastrophically when there is something called stigmergic signal or the pheromone trail gets corrupted. This is something that might happen, for example, with ants. If ants follow a loop, okay, they will walk in circles until they die. Why? Is because they apply local rules to follow the path that has been defined by the others. But if this path, for whatever reason, closes on itself on a loop, all the ants will keep following and amplifying that path, and it's called the ant mill. It's a real phenomenon, and it's fatal. Okay, which makes sense because you would see these ants trapped on the loop. They will never go out because they have no reason, and then they will starve. Now, social media engagement feedback can create exactly the same failure mode at civilization scale. So the pheromone trail is the engagement, and if engagement points toward outrage and tribal validation, the swarm follows it, and the swarm is people. Okay. Not toward food, but in circles. Burning energy, going nowhere. Sounds familiar? Now, how can we fix all this? Actually, engineering better dynamics. The very first thing that one might think of is, okay, let's reintroduce negative feedback, and that would be a fix at a systems level, which is pretty clear. You add carrying capacity back in. What does that mean in practice? Well, you have diversity floors that is mandate that recommendation systems show a minimum percentage of content from accounts below X follower count. Essentially inject new nodes into the network before they have proven themselves. Okay, so that creates diversity. Decay functions is another approach. Engagement signals should decay over time. I know that they will never do it because that they lose money if they do that. But engagement signals should decay over time. Content, for example, from 3 years ago that went viral 3 years ago shouldn't permanently boost a channel. This is how natural systems work. So old pheromone trails evaporate. That's why having the ant mill in nature is still possible, but it's very unlikely because pheromone evaporates in the air, and eventually that circle that will be broken, right? Exploration exploitation balance. This is a concept that, of course, we have in nature and we have copied in reinforcement learning, for example. The agent that decides to explore or exploit the current optimization function. Recommendation algorithms already use this in theory. Think about the so-called multi-armed bandit models. But exploitation, that is showing you what it knows you like, dominates most of the time, right? Why? Is because it generates immediate revenue for, of course, the platform owners. So the idea would be, or well, this one possible solution would be to force more exploration instead. Deliberately surface things outside your engagement profile. And that's pretty much what happens, or I've seen happening a lot more, for example, in Blue Sky and Mastodon, where there is no orchestration and ordering or sorting of my feed. So there is a lot more space to people who are not even in my circle, and they appear on my feed just because they sent something that is matching a tag that I'm following or something. So you can see these things, and I must say that yes, it's less accurate with respect to my current interests, but it gives me a chance to exploring and finding new things that I would not otherwise. Another thing is changing the objective function. This is a lot harder, but of course more fundamental. So right now, as I said, they are maximizing engagement. What if instead they would maximize engagement plus or times epistemic quality, right? So epistemic quality is something like information gain, diversity of sources, as I mentioned, accuracy signal from expert communities. It's not utopian, it's an engineering choice. The platforms could do it overnight if they wanted. They choose not to because it might reduce short-term time on platform metrics, and therefore less ads targeted, and therefore less money, essentially. I think that there is the EU AI Act that is beginning to push in this direction. I have to double check that. They are mentioning, they require more transparency in recommender systems for large platforms under the Digital Services Act. Maybe I'm going to do an episode about that, but of course I need to educate myself on that very topic. It's a regulatory attempt, however, to reintroduce negative feedback through compliance pressure, because if you force platform providers or platform owners to follow certain rules, they can change their technology according to whatever is the rule and the legal framework they are under. Okay, so the other thing is protocol, might stay there still, protocol versus platform. So the longer term fix is, of course, architectural. So the internet was designed as a protocol, open, federated, nobody owns it. So we had things like HTTP, SMTP, IRC. These are all protocols, all right? Your email address, actually, SMTP, IMAP, works with any client. Why? Because on any server, any client. Why? Because they talk exactly the same protocol, right? Social media was designed as platforms, not protocol. So social media were designed as in a closed, centralized, winner-take-all fashion. So the difference matters enormously for rich-get-richer dynamics, because on a protocol, there's no single algorithm that is controlling amplification, while, of course, on a platform, one company's optimization function determines what the entire world sees. And that's the biggest difference. Projects like ActivityPub, which I mentioned under Blue Sky and Mastodon, are the typical two Twitter equivalent, but with a different protocol. These are attempts to return to the protocol model. They are not perfect, I must say. So rich get richer still emerges in federated networks, which is kind of okay when it's under control. But the absence of a single engagement optimizer means the dynamic is less severe and harder to exploit. Okay, so what What you can actually do about all this. So the platform won't fix itself tomorrow. Don't lose your hopes. So what do you do? Well, first, understand you are inside a positive feedback system. Your starting point matters more than your quality on any given day, right? This is demotivating but important. Don't confuse algorithmic invisibility with lack of value. The second point is seed the network at multiple attachment points. So IRC was egalitarian because everyone entered the same channel. On modern platforms, you can approximate this by seeding content across platforms, in communities, via newsletters, in podcasts, anywhere the recommendation algorithm has less control. The third thing you can do is build direct relationships that bypass the algorithm. Think about emails, lists, Discord communities, RSS feeds, if there is someone who uses RSS feeds. These are low follower count, high signal channels where your audience found you deliberately, not because an algorithm decided to test you on them. And so the goal here is to create your own positive feedback loop that doesn't depend on the platform's version, right? Now, I want to give you the verdict about people who believe in the rich get richer model being a natural thing and people who believe about artificial dynamics instead. I think they are both right. Okay, rich get richer is natural. It's how swarm systems self-organize. After all, it's how evolutionary pressure works. But it's also how forests grow after storms and many other phenomena in nature. Artificial dynamics, like the internet, it's also correct partially. The internet is artificial, and artificial systems have designers. When those designers removed the natural feedback, negative feedback that keeps positive feedback loops stable, they didn't just replicate nature, they created a pathological version of nature. Nature runs preferential attachment within a carrying capacity. Okay? Social media runs it without one. So the ant mill is real. You can watch thousands of ants spiral to their deaths following a pheromone signal that loops back on itself. No ant is stupid, it's just that the signal is corrupted. The question isn't whether rich get richer is natural, the question is what kind of systems do we want to live in? One where the feedback loops are tuned to extract attention, or one where they are tuned to produce something worth paying attention to? I will give you some time for thinking about that. I'm Frag, this was Data Science at Home, and don't forget to follow us on datascienceathome.com. Talk to you next time.